Good evening, everyone. Can everyone hear me? Great. So, thanks for the introduction. I'm Nicholas, third year PhD here at Newcastle University, looking at the remote sensing of hedgerows, specifically in the UK context, UK farmland. I work also with FERA, who are a commercial research organisation based just outside of York. So they provide some assistance and equipment, basically. So I just thought I'd start by saying agriculture takes up a lot of the land surface. It's the biggest land use globally, and it often gets a bad name in terms of contributing to the ecological crisis, contributing to climate change. But I like to see that slightly differently. I like to think that small improvements on a large area can have quite an outsized impact on those things. So I'd say that's sort of where my interests lie in terms of research and otherwise, how agriculture and agricultural land can help contribute to solving some of those crises. On the right here, there's a map from a few years ago of hedgerows in the UK. It's worth noting hedgerows aren't specific to the UK. Northwestern Europe has a few countries with them as well, although they're most common here. So I guess I should say a few words as to what hedgerows are and why they're important. So they're a managed line of shrubs, and I emphasise the managed because otherwise they're just a line of trees, and that's not a hedgerow. And they have many particular benefits to lots of different species, be it mammals, invertebrates, and many others as well, which rely on them for habitat, for food, for provision of other sort of environmental, ecological services. And we as humans as well rely on them culturally, so sort of a distinctive feature of the British landscape, and people come from all over the world to appreciate it. So just some of the reasons why it's important. So I've given you the definition, a bit of the history. So originally, it's thought hedgerows came about to act as a livestock fence. So sheep and cows and other animals sort of were protected before fences came along. So fences have sort of taken that important role away from the hedgerows, which means land managers, farmers can get away with managing less intensively. And they're under other pressures economically, so they want to be doing as little as possible in that respect. But talking about money, the government and DEFRA understands the importance of hedgerows, so they pay farmers to maintain them and to keep them and to plant new ones, as well as to plant trees and things like that to improve the hedgerows. So I don't know if you're aware of the current situation post-Brexit. A lot of these farm subsidies are changing, and there's recently been announced a new way of rewarding farmers for improving their hedgerows, which rely on them doing assessments of the hedgerows, which is where sort of remote sensing fits in, which is basically not sending someone in to do the work. You can use tools and machines and drones and things, which I'll go into more detail on, to do the work for us. And I'm trying to figure out how we can get that data into something usable for people like the government or other interested parties to use to be able to say how well it's going. So the Committee on Climate Change in the UK specifies for hedgerows their target is to increase coverage and size by 40%. I think it's by 2040, which will obviously involve a lot of efforts in planting, but more importantly, efforts in measuring that, because at the minute there's no way of knowing how we're doing in terms of reaching those goals. So I'll skip on to the next slide. So in terms of studying them, they are quite important, as I've said, but they're also quite difficult to study. So a lot of studies have focused on trees or other more widespread and easier to measure habitats, such as forests, which are spread globally, so they haven't necessarily received as much attention as they are due. So, but that could also be due to some of the difficulties. So obviously, because of what they were, they were chosen as livestock-proof barriers because they're very prickly, because they're very spiny and hard to work with. So it's quite hard to study. But that doesn't mean it's not important in terms of storing quite a lot of carbon, storing carbon in themselves, so above ground carbon, but also increasing soil carbon stocks around them. So, and that's not even talking about ecological roles in supporting all the other species that rely on them. So for my project, to get the sort of full views, I interviewed a few different stakeholders, from conservation type charities to environmental government bodies to environmental charities, to sort of see what elements were important to them in terms of what they'd like to see conserved or what they'd like to see improved on. So in the bottom right corner are just an example of a few of these. So things like the volume of it, the density of it, the number of stems. So you can see in like these three specific examples, between the two poles it's about 2 meters, and you can see there's a huge variety in terms of the stem numbers. So in a much older hedgerow, which is being quite heavily managed, it almost turns into a bonsai tree. There's barely any stems left. They're getting quite old. Whereas in the younger ones, there's a lot more, which provides a lot more cover for a variety of species, and at the same time can store quite a lot of carbon. So just in terms of getting everyone on the same page as to what remote sensing is, remote sensing is the use of sensors to go and get us information instead of us having to do it manually. So there's two main categories. The first being passive remote sensing, which is what we have on our phones, what you have that you use in a camera or even satellites. You're basically using the light from the sun to reflect on an object, and you're measuring that reflection. And then, so that gives you information about the surface that it's reflecting off. And then the other category is active remote sensing. So in that one, the sensor is releasing the light, and it knows how much light, when, and which direction it's traveling in. So you're actually looking at when it bounces back off something, how long it takes to travel. So from that you can start to, because we know the speed of light, tell the distance of things, so you can start to get spatial information and structural information, which is more useful, especially besides getting the 3D shape of things, it can also penetrate. So certain laser light pulses will penetrate through a canopy, will hit branches, or will hit the ground, which is quite different to just a pure camera, which will get the surface of things. So for estimating sort of biomass and branches and structures, it's a lot more interesting to have this sort of data, but it comes at a cost. It's more expensive, it's harder to manipulate, harder to use. So in my PhD, I'll show some more pictures later, which kind of help hopefully bring it to life a bit more. I've combined a few different data sources from cameras and laser scanners at different levels and on different tools. So there's airborne laser scanning, which has been done by planes, by government agencies, which is freely available. I've also flown some drones with that same technology, as well as just plain camera, as well as laser scanning on the ground and just ground-based cameras. And the idea is to pull different sources of information together and extract certain parameters to look at the parameters of interest from my interviews at the start. And And I should say the middle section here, the carbon and the biodiversity indicators, is really what stood out from those interviews. It's what most people are interested in. And then at the end of the day, hopefully that will be useful to some people. So in terms of the work I've been doing, I was doing this at the university farms up at Cockle Park near Morpeth, as well as the other one on the way to Hexham, and also at two estates, Wallington and Castle Howard near York. But basically, there's different tools. There's a drone-mounted laser scanner, which can tell information more internal to the structures, and there's the cheaper camera, for example, in the bottom picture, and then as a bit more of an accurate method, but that doesn't scale very well because it takes a lot of time, there's a laser scanner in the top left. But at the end of the day, it all comes down to cost and balancing that with multiple different things, including the scalability, the ease of use, the accuracy, and a few other things. Because at the end of the day, if this is to be useful to anyone, it has to be usable, but also at a price they can afford. So to go from all of those measured parameters from all those different tools involves quite a lot of ground truthing. So that is doing checks, either using hand measurements or measurements we know to be accurate. So using cameras, using just tape measures for height and width and other things. And then trying to relate that information versus the sort of estimates from various models using the information from the data, from the remote sensing data, basically. And another piece of work that I was doing involves the ground truthing of the biomass. So we can have great models as to how a hedge is branching and know the size to a very good level of accuracy. But at the end of the day, if we don't know how dense it is and how much it actually weighs physically, then it's not that useful. So there was quite a lot of work done at Cockle Park about this time last year, actually cutting back quite a lot of hedge to weigh it and dry it and to get more accurate methods, which is not really been done much before. So it's kind of excited to see what comes out of that, basically. And that's the end of my talk. So I've left my email address and Twitter and LinkedIn if you're interested in finding out more. Happy to take questions and having hopefully some discussion afterwards. Thank you.